The Texas Department of Transportation and the University of Texas at El Paso studied the upper limits of field sands to determine how they may impact Superpave mixtures across the state. Field sands are used in pavements to reduce costs and binder requirements, but their use is limited in part to their impact on overall road performance.
So in the black roadways that you drive on, there is a coarse aggregate, intermediate aggregate, there's a fine aggregate. Typically that fine aggregate is going to be either like a crusher fine, so if you're using limestone, as you're producing limestone in the process of crushing, you generate dust. So that's going to be more of like a manufactured sand, right? You're just naturally creating that in the crushing process. East Texas uses a lot of like river gravels and granites and things like that, so you have less of those. And so typically your sands are going to come from natural sand sources, which are unclean sands from things like riverbeds.
And some of it has expansive clays and or volatile clays, which translates to expansive clays, and clay and water doesn't mix well. So that can lead to a lot of stripping that happens on the pavement, and that can happen very fast. There was several projects they start constructing. Within 6 months, they were having a lot of rutting failure. And the understanding is why this early failure is happening.
Historically, we had a test called sand equivalent. And so sand equivalent tells you how dirty the sand is, how much clay is on the sand. And so it passed all of those tests, and then we still had pretty bad failures rutting and stripping in the field. And so we started looking at another test called methylene blue. And the methylene blue gives you the reactivity of the clay. Not just the quantity of clay. So when we ran that sand, it was very clean, but the small amount of clay that was on it was very reactive, and it caused failures. So we started this field project to look at all of the field sands throughout the state to see what combination of sand equivalent versus methylene blue we could utilize without seeing the pavement failure.
We ended up with 25 sources of field sands that they think they use that they would like us to look into. So we looked at them, and sure enough, we start seeing that, yes, some of these field sands are very volatile because of that amount of clays they have in them, and they do affect early age failures.
We did come up with a rough guideline for that, and then we're actually taking this into an implementation type project through an interagency contract with the university so that we can do more field testing on specific mix designs utilizing those materials, and then we're going to check for stripping using the Hamburg wheel tracker test.
You don't have to do any other test that they don't do right now. We're not coming up with a new test. It's interpretation of the Hamburg data that comes out of the Hamburg test. You look at it and you can calculate a stripping value. If that stripping value is above the limit, then you're going to have issues in terms of early failure. If it's not, you're going to do well.
One project in particular, it was failing before it was open to the traveling public. So we're trying to prevent that from happening again, but we also don't want to limit available sources. So if, like I mentioned, East Texas has locally available material on site, if we just say you can't use it because we don't want any failures, where's that sand coming from? Right? And that means they have to rail it in. So all of a sudden, projects increase pretty drastically in price.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.